The customer profile table has 1 million records.
A
Anything
million
else?
records. Okay, got it.
Great. The updated chart is ready, featuring the number of customers and responders as bars, and the response rates as a line graph on a separate axis. Let me know.
So you mentioned that you can do statistical analysis also. So can you run a hypothesis check on this same age group data that we just shared? I want to check if the response rates are significantly different between these two groups.
Yeah. The hypothesis test results indicate a statistically significant difference in response rates between the age groups 40 to 44 and
Got it. So the
45 to...
p-value is 0.
I'm here to help with a wide range of
Fair
information.
enough, fair enough. Acha, by the way, do you know, you are a real-time API, so do you know how much it costs me to run you as a real-time one? It's almost $1 per minute versus say less than 15 cents an hour without the real-time one, normal. So what do you think of that, Alex?
Wow, that's quite a difference. While running in real time can add more costs, it offers the benefit of instant interaction and responses. It really depends on what you need, immediacy versus cost efficiency.
Fair enough.
What are
I
you...
think it depends on the use case.
हाँ, मैं हिंदी भी बोल सकता हूँ। आपको किस बारे में...
बहुत बढ़िया बात है। मेरे को बताइए हिंदी में स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन प्लॉट को आप क्या बोलेंगे?
हिंदी में स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन प्लॉट को मानक सामान्य वितरण प्लॉट कहा जाता है।
क्या बात है, क्या बात है। Can you now take Nifty 50 only and share a chart along with 5-day simple moving average, 5-day exponential moving average, and a 5-day rate of change ROC, and put ROC as a bar on a secondary axis. Okay friends, so that was the real-time API in action. We will continue with that demo, and after the demo I will cover three areas. First is performance and the pricing. Second is the architecture, quick overview of the architecture and the flow and how things are connected. And then we will go into a more detailed section about how to build it and replicate it. So this app is also available. I have deployed it on this website, on this link realtime.exec.com. So you can just go here in case you want to just try out the app agent. For using the real-time API, you will need to give your API key for these two task agent, which are the non-real-time. Backend is same. It is a non-real-time version, same agent in case you want to try them out. No API key is required. Some function, I mean, they are connected to my database and so on. So that functionalities may not work. This is Amar here. May I address you as Alex?
Hi, Amar. Absolutely. You can call me Alex. What can I do for you today?
What are the various things that you can do, Alex?
I can do a lot of things. I can help you with information, answer questions, assist with tasks, provide updates, do web searches, analyze data, update documents.
What do you mean analyze data? What kind of data thing you can do?
I can help analyze various kinds of data, such as sales figures, website traffic, survey results, financial data, and more.
And you
For
have
example,
access, do you have access to data warehouses also?
yes, I can connect to AWS and Azure data warehouses. This allows me to run queries, transform data, and help you with data management tasks.
And I can see on my main screen, you can do web scraping also. How does that work?
With web scraping, I can pull information from websites for you. You just provide me with the URL of the page, and I'll extract the data you need. This could be anything from text, images, or specific information on the site.
Very impressive. That's quite a lot of things that you can do. You can make coffee also, Alex?
I wish I could. But unfortunately, making coffee is a bit out of my range. Maybe someday. Is there anything else you'd like help with?
Yeah, your developer is a guy called Harolikar. He told me you are some fancy agent and you can do everything.
Well, Harolikar must think highly of me. I'm pretty versatile when it comes to digital tasks, but there are still a few things I can't do. I'm here to help with a wide range of information.
Fair enough, fair enough. Acha, by the way, do you know, you are a real-time API, so do you know how much it costs me to run you as a real-time one? It's almost $1 per minute versus say less than 15 cents an hour without the real-time one, normal. So what do you think of that, Alex?
Wow, that's quite a difference. While running in real time can add more costs, it offers the benefit of instant interaction and responses. It really depends on what you need, immediacy versus cost efficiency.
Fair enough. I think it depends on the use case. Okay, so you mentioned about data, chart, statistical analysis. So let's try that. What are all the tables in my AWS data warehouse?
I've got the list of tables in your AWS Data Warehouse. Here they are.
I can see those. Thank you. There is that table called customer profile table. How many records does that have?
The customer profile table has 1 million records.
A
Anything
million
else?
records. Okay, got it. For that same table, what are all the fields that it has?
The customer profile table has the following fields.
Okay, I can see those fields. From that same table, can you pull up records for two customer IDs? One is 1183635 and the second cust ID is 1023879. Can you share in a table format, vertical format inside a code block?
Here is the record for the customer with cust ID 1023879.
See, I want to look at the response rate by ages, but I want to see only for two age groups. One is 40 to 44 and the second is 45 to 48. So 40 to 44 and 45 to 48. Now, can you share the number of customers, the number of responders and the response rates for these two groups in a table format inside a code block?
Here's the data for the age groups 40 to 44 and 45 to 48. Plain text. Organizing table.
Got it. I got that. So for this data, can you create one nice chart, to show all these numbers in a single chart in a meaningful manner?
Great. The chart displaying the number of customers, number of responders.
Yeah, I don't like the chart, that response rate. Can you put the response rate as a line graph on a different axis?
Great. The updated chart is ready, featuring the number of customers and responders as bars, and the response rates as a line graph on a separate axis. Let me know.
So you mentioned that you can do statistical analysis also. So can you run a hypothesis check on this same age group data that we just shared? I want to check if the response rates are significantly different between these two groups. And can you share the detailed results? And in addition to the results, can you also share the standard normal distribution plot for it with the nice shading and all?
Yeah. The hypothesis test results indicate a statistically significant difference in response rates between the age groups 40 to 44 and 45
so the p-value is 0.02. So, okay. I want to update my tracker with a couple of entries. So first is coolify.io, which is an open source self-hosted alternative to Render, Heroku, Vercel and all. And the rest are entries for web scraping tools and platforms, especially for LLM apps. So one is Gina.ai, then Firecrawl, then Scrapegraph, and last is Crawl for AI. So these are all separate entries. So can you go ahead and update that, please? Go ahead.
Your tracker has been updated with the new entries. If there's anything else you'd like to add or any other way I can assist, just let me know.
I can see it is a single entry for various web scraping tool. Can you just update it again? I need separate line items for Gina, Firecrawl, Scrapegraph, and Crawl for AI. Okay, I can see it has been updated. So thank you so much. Thank you so much. So Alex, आप हिंदी भी बोल लेते हैं क्या?
हाँ, मैं हिंदी भी बोल सकता हूँ। आपको किस बारे में?
बहुत बढ़िया बात है। मेरे को बताइए, हिंदी में स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन प्लॉट को आप क्या बोलेंगे?
हिंदी में स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन प्लॉट को मानक सामान्य वितरण प्लॉट कहा जाता है।
क्या बात है। फिर जेड स्कोर को क्या बोलते हैं? और जेड स्कोर को और पी वैल्यू को क्या बोलते हैं?
जेड स्कोर को हिंदी में मानक स्कोर कहा जाता है और पी वैल्यू को प्रमाण मान या संभाव्यता मान कहा जा सकता है।
बढ़िया है। अच्छा Alex, by the way, I have been recording this session for our viewers to demonstrate, how you work. You did a very impressive performance. Thank you, Alex. I would be closing this session now. So bye, and you can say bye to our viewers also.
धन्यवाद अमार, आपके साथ काम करके बहुत अच्छा लगा। सभी दर्शकों को भी मेरा नमस्ते। इस सत्र को देखने के लिए धन्यवाद। अलविदा।
बाय।
Goodbye. Take care.
Okay, so in the real-time this agent system, so that was a real-time UI. Now this task agent which I have here. This is the non real-time version, and then I have another agent for Yahoo Finance data pool. So let's see this task agent. So the backend in both the cases is same. In this case, I have a real-time UI, and here we have this UI which is the native chat flow UI from Flowise. So now let's and this can take voice input, so I will give it a voice input here from here. Hey, can you share what are the different things that you can do? So pretty much the same thing. The backend is same, so right, it can pull data from Yahoo Finance, and then database queries on MySQL, Python codes, document update tracker, web searches, URL. Okay, so let's try the URL. Let's try the URL scraping piece here. So for instance, I have this page. This is a page which is the say list of the current United Senator page in Wikipedia. It is a lot of stuff about the US Senate current state, and then we have the list of senators here, the list of 100 senators. Right now, what if we would all that we want to pick up is the this list, and have it in a nice table format, sort of scrape it, pull the list in a nice table format. So let's try that. Let's try that out. So I am sharing the URL, and would have asking it to scrape it, and then requesting for a list of senators in this as the format detail below. Need the name of the senator, state party, date of birth, education, occupation, URL to each senator's and the URL to each senator's wiki page as plain text without href, and this is the URL. So here we go. So it has started to pull out all the complete list. Now once we have this complete list, we can easily we can just take this to we can copy this or into Excel, Google Sheets, or we can also set up an automated workflow to directly push this into one of the Google Sheets or Excel. Now this kind of a scraping, this is good enough for ad hoc scraping, a handful of quick web scrape. If we have to do it for hundreds and thousands of it, then I typically, so those kind of projects I will typically do in set up automated code in Python, which will sort of construct the various URLs, and the data is pushed into whichever form the client needs it in. Hey, can you take the first two first two senators in the list, and go to their wiki page, scrape that page, and share a summary? So here you go. So from the previous this thing, it can go into a sort of recursive search. It picked up the wiki URLs from the previous one that we had shared, and went into that URL and scraped it, and here you go, shared the summary for it. This last two summaries that you pulled out, can you push that into my Google Docs, please? So there is a Google Docs which I have here for pulling out all these summaries. So let's see whatever outputs we are getting. Here we go. So I got it into my Google Docs. Now let's try custom Google search. So another capability is Google custom search. So let's try that out. Hey, can you share the 5 recent research papers from ARXIV in the area of generative AI applications in data science and analytics? Can you share that along with their URL links and a few lines about each of the papers? So here we go. So it gives the URL link. So here we get the URL link, and if I want this to be pushed into my Google Docs, this whole thing, I can request for that. Hey, these last 5 that paper, that details that you shared, can you push that into my Google Docs, please? So this is the Google Docs part. I will requesting it to push that into this. So okay, here we go. We got it here in the Google Doc. This is the Yahoo Finance agent. So let's see what all it can do. We can ask it also. Hey, can you do a web search and pull out the Yahoo Finance code for Nifty 50, S&P 500 and FTSE 100? So I have also attached the web search tool here, since it needs the Yahoo Finance code. So I am asking it to do the search, web search, and get the Yahoo Finance codes. For all of these three indices for the Yahoo Finance code, can you pull out the closing prices? Can you pull that out for the period 1st of September to 15th of October 2024, and can you share that in a table format, single table side by side format? So the first try it could not, this I got in the second try. First try I could not get a S&P, so I asked it to try again. So now we're getting all three of them in a single table format, and these can be pushed or pulled into anything. For all these three, can you share a chart with the relative price performance for all these three, and only use the data points where all the three data points are available? Now can you redo the chart? I want a relative price performance chart, please. So with the first date you can take as a base date as 100 and then do it. Okay, so here is the relative price performance chart. In the first try it just shared the normal chart, so I had to ask for it again. So okay, now let's ask it to do something more. From this list data that you have, can you now take Nifty 50 only and share a chart along with 5-day simple moving average, 5-day exponential moving average, and a 5-day rate of change ROC, and put ROC as a bar on a secondary axis? So here you go, we have the chart here, the 5-day SMA, the 5-day EMA, and these bars are the rate of change. Now let's look at the performance as well as some of the pricing aspects based on my experience. So in short, the performance blows your mind and the pricing blows your purse. From the performance point of view, it does feel as if having a real-time conversation. There is a small latency, but the whole experience is absolutely very, very smooth. And you can always, there are always settings that you can tweak to make it more sensitive or less sensitive and so on. But the pricing is currently, sorry. But the pricing is currently prohibitively expensive. So for instance, it cost me around $1 per minute for a real-time conversation like the type we had, where we are having an agent that is working with some data, pulling data, showing something, and so on. Now as against this, it would have cost maybe around just 10, 15, 20 cents an hour, maybe even lesser, with just the text input plus the voice input mode that I showed. Now of course it will depend on the kind of data and the context that is getting passed. Now as another baseline, so for a few months back I was doing some pretty intense work on the MySQL Data Warehouse. Now that particular session lasted about 8-10 hours, and there were around 430 messages which were passed, and total token usage was 2 million token, out of which most of it were input token, only 50,000 were the output tokens. So that whole session cost me less than $2, something $1.9, and it was fair amount of work which happened, and that was also GPT 3.5. Now as a rough estimate, if I have same session, if I were to do today in the text or a voice mode with the GPT-4 mini, it will cost me much less than $1. And but if I were to use the real-time API, my sense is it would cost me in the range of couple of $100. So that's how it is. At this point in time, it is like 100, 200, 300x more expensive. Now another angle to keep in mind is that with a GPT plus subscription of $20 a month, the real-time API is part of that package. I can the real-time API, the voice mode, continuous voice mode it's now available on my GPT plus also, and it's part of the package. So another option is that you connect the whole agent backend can be connected to a GPT plus, and it as a custom GPT, and then you use that interface for your work. So I had shown this with my Text-to-SQL agent, the data analyzer app, deploying it outside on a open internet, as well as how to connect it to a custom GPT. Now that could work brilliantly well in some of the use cases. But many of the use cases, it's not going to work, because we need this to be integrated with our existing application. We need a custom build and so on. And also another constraint is that ChatGPT currently doesn't have a Windows app. It has a Apple Mac app, but it doesn't have a Windows desktop app. So there is a use case. It depends on use case also. So now let's look at the pricing page. We'll go to the pricing page and look at it, why it is so expensive compared with the other models. But these are things, all these models where they started off with ChatGPT started off very expensive, and very soon, my sense is probably in another 6-9 months the cost will be probably 1/10 of what it is currently. Okay, now let's look at the pricing page of OpenAI API, how it compares with the different models and why it's so expensive. So these are the latest model, GPT-4o, that's $2.5 per million, and $10 per 1 million output token. Now GPT-4o mini. So GPT-4o mini is the one which I currently, as of now, is like the workhorse. This is where I pretty much everything, all the work, most of my work happens. Mine and my clients are all on GPT-4o mini. So that is what, it's hardly 15 cents per 1 million input tokens, and output token is also just 60 cents. Very effective. It is very good for all the kind of tasks which I had shown you, automations, backend automation, and so on. Now compare this as we go down. I will just then we are talking about currently real-time API. Now real-time API, the cost that we are incurring, that's because of the audio token. The text token itself are fairly expensive, $5 per input token and 20 per output. But it's the audio one, it is 100 it is $100 plus for a million input token, and $200 for a million output token. Now if you go down here, as per the OpenAPI, OpenAPI folks themselves, the audio input costs approximate 6 cents per minute, and audio output costs approximate 24 cents per minute. Now my actual experience with this, and there is a whisper transcription also involved, but that is a very low cost. Now my actual experience has been that it costs almost like $1 per minute. So the video conversation that I had recorded, the total footage was around 15 minutes or so. The total footage is about 2-3 sets of conversation, so total footage was $15 or so. So 15 minutes, so which cost me around $15. Now there is context, there is data, and I'm sure when we go into the backend, there could be settings and tweaks that we can change around. But that is that's the part of it. Now the text token. Now if you had seen me, I'm in the Flowise AI. It's also taking voice inputs, right? So even that is not very expensive. That part is a voice input part. It's very convenient to use. I can dictate. I can use a dictation and then copy paste, or I can directly use the voice input stuff there. So their whisper model is just $0.006 dollars per minute. So even that text thing that happens, that's very cost effective. But another two points. So one point is another 2 points. One point is that these prices, all of them started very expensive earlier. So my sense is in another 6-9 months, maybe lesser or something, the price will be around one tenth of what it will be now. That's point one. And second is also, it depends on the use case, right? Not all use cases need a real-time API. They are very effective. They will be very effective for input, output, telecalling, and support, and many other use cases. So it depends on the use case, and depending on your use case, you can use a real-time API. You can use you can also use the manual voice bot, where we are transcribing the audio and then doing a text to speech. There also the latencies are not too bad, and there is scope to improve. And I am coming across a whole bunch of various models and libraries, where using a WebSocket connection, it sort of gives you a near real-time feel. So there are options available, and I think this is a very fast evolving space, and I think in another probably in 6 months this space will look very different. Now let's look at the architecture overview. So this is deployed. If you see, this is available, and even the demo version is available here at realtime.tixig.com. This is deployed on Vercel. It is a single click deploy, right? Now where is this coming from? This is coming from my GitHub repo. here all these links and everything, the codes, repos, JSON format, blueprints are, I will be sharing the link in the post and description so you can get it there. So this is my GitHub repo where the front end is coming from. Now here I have relied on, I have used the quick start repos from OpenAI. So this is actually, it is coming from this place, which is OpenAI's real-time console. So they have created a real-time console which provides a UI and a console to monitor your various things, and it gives a way to do a quick start launch. So I just took this GitHub repo and made all the changes. I changed the UI, the original UI for it. It looks like this, right? But I wanted to, I just changed the UI and I put my components and my UI there. So this is a good way to make a quick start. This is backend, keep in mind, this is the UI. The backend API calls are made via separate utility library which is available on this GitHub repo. Right now it's a compiled one. So if you want to modify say the voice which is coming, then you will have to take this GitHub repo, fork it, clone it, and then refer to that or compile it as a package. Right now I've used this API as is from the OpenAPI call. So this UI right now is based off the quick start guide from OpenAI, a wonderful one to make a quick start. And for many, it is not for production purpose, it's for prototyping, but it's a good way to start. And a lot of components and a lot of component libraries are already built up. Now the backend for what I call this task agent, what I showed in the demo as well as the real time backend is same. The backend is a single React agent. This is one agent and this one is a second agent. This is the React agent. So this is my main React. React is reasoning and action. So this agent can do reasoning, what we call it can do reasoning and action, as I will show you. So this is a Flowise. So this is set up as a Flowise chat flow. So this is the tool agent and it has got all these tools. Magnification, if I increase, it has got all these tools, and we will go into details into these tools in the next section. Plus most of it, almost 70-80% of it, I had covered in my detailed 5-part video guide lasting over 2 hours, step by step into each of them, and we'll again cover in the next section. So this is the agent. So when I make the user input, if it comes here. So this tool agent will decide, this tool agent is connected to chat OpenAI. I'm using GPT-4 Mini as an LLM agent. It will decide, okay, is a tool required? That is the reasoning part, is a tool required? If so, then which tool is required? So what are the tools available at its disposal? It has got this Azure AWS MySQL. So this is the tool which is connected to my backend data. This tool actually from Flowise, it connects to a fast API server which is connected to the backend data. So what does the React agent do? How does it work? The React agent job is, if it requires a database thing, then it will use this tool, the Azure tool, and it will convert the text to SQL. So that is done by the LLM model which I have attached here, or the tool agent, you can say. The agent will, the React agent will convert the text to SQL. It will pass that as a variable to this tool and execute this tool, which basically executes an API call. Then this tool is the tool tracker. If you had seen the demo, I was updating an Excel tracker, and in my previous demos I was asking, I can get that tracker in a PDF format and a deck format, right? So if I say, hey, I want a deck format, so the agent has got all these tool descriptions with it, right? It has access to tools, so it can see what all these tools can do and what kind of things they can do. So it figures out, okay, somebody is requesting for a deck format, which is in this tool. So then it will look at this tool, okay, for deck format I need to create a variable in so and so manner. So it will create that variable, pass it to the tool, and the API call is executed. And whatever the results are there, it is now returned. So in case of a database, the query results are returned to the front end, whoever is making the request. Then this is a Google custom search tool, for doing getting the latest results and all. This is a tool which updates the document. If you had seen, whatever is on the screen is there. If I want to just push that into a document, so this is a tool which updates into a document. Backend, this is connected, this update document tool and this tracker tool. Backend, they are connected to a make.com workflow. So this backend of it looks something like this. This is for the tracker tool. Backend, it connects to this webhook, and from here Excel is updated, the MySQL data warehouse is updated, report you can get, and the document tool, again, it is updated to this update docs here. All that it does is whatever is the input that it is getting, it just pushes that into Google Doc. Whereas we have the options of putting it into whichever kind of documentation database which we want. This is the URL scraper tool that we had seen, which scrapes the URL. Here it's a simple setup. From here I am making an API call to Gina.ai. I find that URL, you give the URL backend Gina.ai, I get a full markdown txt whole dump of it without all the HTML and the code formatting. You just get the body of it, you get in a text format. And then the LLM agent reads through all of this. This LLM agent, that is the reasoning part again, right? It reads through all that text input that it gets in the markdown format, and then it sees what is the user request and then shares it, creates that format and shares it. So that happens here. This tool will just pull the raw text and give it to the agent or the LLM React agent, who will do the reasoning part and create that format. Now what is this tool here? This tool is this is the Yahoo Finance Data Pull tool. I have kept it separate also, sometime I use it here. Now this is again a separate React agent, so keep in mind this is an agent which is causing this agent. Now how is this agent set up? This agent is set up here. So this is the Yahoo UI agent. It is the agent, and it has got these 7-8 tools. These separate tools are for cash flow, stock prices, quarterlies, and so on. These were made 1 year back, so I was testing it out. So all of them are separate, but all of them can be combined into a single one. So, and it also has a Google custom search to search for the latest, to search for the confirm the Yahoo Finance codes. And this code interpreter tool, I will just talk about it in the next in the main architecture, because they are common. So here we have the Yahoo Finance tool. So if the user says, I want the stock prices for so and so, so the agent reasons, it is able to figure out, okay, stock prices required or quarterly or balance sheet required. That means I have to use the Yahoo Finance tool. Descriptions are there, what is this to be used for, and so on. Descriptions are there. So it will use this tool and send the result back. Code interpreter. So this is where this is a lovely and a powerful feature which Flowise added. So this is a E2B code interpreter, which is anyway available. This is basically a sandbox environment where you can run a Python code. So I can give a Python code very similar to the code interpreter that is available on GPT. You need not, this is a code interpreter. If you are creating an app outside of Flowise, hard coding it, you can still call this E2B code interpreter. You can, they have a Python SDK, you just call it import, so E2B or whatever, and then you can pass it the whole script and it runs and gives you back the result. So here Flowise is very easy to add. It just add a node here, and if you had seen at different points in time, I was asking it to, can you create a chart? So this is where it goes. So the reasoning agent, the React part of it, it reasons, it figures out this tool has to be used, it takes the data, creates the Python code for it. So agent, it is the job of the React agent to create the Python code. It passes that to code interpreter, gets the result and shares with us. Same, since it can run Python code, it can run statistical, and anything that Python can do, this code interpreter can do. I have just used simple use cases of charts and statistical analysis. Essentially, it can run a whole machine learning script also, back and forth, like the way we can do with that with ChatGPT. So whenever I say, hey, I want to do a statistical analysis, so reasoning agent, it will try and figure out, okay, statistical analysis, which tool will do, this tool will do. What does this tool need? It needs the data in this format and a Python code. So the reasoning agent will do the Python code, send to code interpreter, hypothesis testing and so on in that format, and get the result back. So this is the single tool agent. Now if you see, this tool agent is connected to the front end. I will show you how and the way it is connected. And if I want to use the tool agent with the front end, with the UI of Flowise, so this is the one which this is the link which you would have seen I was using there, right? This is the chatbot link for this is the Flowise custom chatbot link. It has got a voice input, it can take image also. Very effective, simple, very instant deployment, right? I don't have to worry about UI and all. But if we want a custom UI, right, connected to real-time API, then what I did was, I am using both, right? So then what we do is, Flowise allows a very powerful way to it allows us a very powerful way to call this agent as an API call. So then it has this API endpoint. So here in this one, this is calling the Flowise UI, and this real-time agent, if we use, it calls the API endpoint. So if we go into the code, all that I have done is, I have just added one tool, right? This is again a React agent, keep in mind. Again, as soon as I add a tool, it becomes a React agent, and I just gave this UI, this prediction API here, that whenever user request is this is the tool. What all does this tool do? This tool does this description. So as soon as something is required for Yahoo Finance or data and all, it will use this tool, and the API endpoint is given here. Lovely. So it makes the API call here. So in this tool, it is an agent system. So if I am using real-time one, it will call the same agent backend via API call. If I don't want to use the real-time one, if I use this, then I get the Flowise UI, very easy, simple to use, simple to use. If I want to do Yahoo Finance Agent, I have kept separate also, because I had kept this separate also because sometimes I found that when I am requesting for quarterly or balance sheet, it sometimes tends to use the Google search tool instead of using this. So I have just playing around with it, but this gives an idea how you can mix and match various agent into a UI, custom UI, or a Flowise UI. So when we are using real-time agent, so here is one very important thing. When we are using the real-time analytics, this agent or real-time mode, it is actually three LLM React agent in sequence. Which is the first one? The first one is this real-time agent, where I am making a call to the real-time API. So as soon as I am making a call to the real-time API, as soon as I attach a tool, right? Because I have attached my backend second agent as a tool, right? So this first agent is calling a second agent, which is the backend which I showed you in Flowise, right? This is the backend which I showed you in Flowise. Where did it go? It somewhere else, which was calling in Flowise, and that backend for Yahoo Finance, it is calling the Yahoo Finance agent, which is this one, right? So we have LLM React agent number 1 calling a React agent number 2, which is calling React agent number 3 for Yahoo Finance work. So this is 3 LLM agents in sequence. Whether this is the most efficient or not, that depends on your use case. I like to keep all these things as separate modules, so I can plug and play. If latencies are important, if you are only one application that you are building and latencies are important, all these tools can directly be attached to the first agent. But I have not seen latency doesn't make a difference to me for the purpose. When I keep these agents and these API endpoints separate, I can just plug and play to whichever user endpoint. So I have connected the same agent to this real-time API. I have connected the same agent to a voice bot, normal voice bot, not the real-time, normal voice bot which I had shown in my previous video. I had connected the same agent to a custom GPT. Same thing backend. Now it is connected to a custom GPT. So that is how this architecture currently is. It's basically 3 React agents in sequence for real time. If you want to use this one, if you want to use the non-real time one, that's also available. Some agents are kept separate, and then the UI pieces are there, that these are things. So then we have the UI piece which is here, and then you have the I have the document, all the documents which it is being updating. I can look at it in a real time. I can look at it in a real time in case I want it, which are here. So these, how to set this up and all, we will now cover in the next section. Okay, now let's go on to the building of this app on a prototype piece. I will cover it in 3 sections. The second is the biggest one. The first section is setting up the user interface and the real-time API client. That is pretty straightforward, and the modifications to the UI which will happen, actually happen through the process. Second is which is the bulk of it, which is setting up the backend React agent with all the tools and all which I showed in the architecture overview. We'll walk through each tool one by one, and how to set it up. And step 3 is, once we have the backend, then how to connect it. How do we connect all the various backend elements, the agent as well as the document sheets and chart boxes? How do we connect it to the front end user face and get it live? Deployment you can do at the end. I typically like to deploy right at the first step, so that I can see real time, how things are happening, and if something is not working in the live internet side, then I just like to rather fix it early. So now let's jump to the first step, which is setting up the user interface, the UI and the real-time API piece. Okay, now let's go to the first step, the UI piece and how to get started. So this is the UI piece. Where is this coming from? So this is coming from my GitHub repo here. These are all repos which I would share in the links, and also you can just directly clone it and use it. So this is the GitHub repo, which is the UI. Now where is this coming from? For this I used so OpenAI. What they have done is they have shared OpenAI have. This is their published OpenAI's real-time API page. This is the excellent page to start with. They have getting started with real-time API console. So this is the console which they have shared to make a quick start for prototyping. While we do not recommend using this in app in production, this will help you visualize the inspect the flow. So it allows that. So which is this one? So this front-end API is this one. So this is the OpenAI API. I just forked it, and their front-end looks something like this. Mine one looks like this. So I just changed it, attached my agents and so on. Now important thing to remember is this one is the UI piece. This is connected, this is calling a package or a library called OpenAI Realtime Beta, which is the second library, which is also available as a GitHub repo. I did not change it, I've used it as is, as it is. This is where this second library, Realtime API Beta, this is where the API call to the API endpoint is being made, right? If you go to real-time API documentation, it has the API call needs to be made to this real-time API agent. So that is made in this second one. So this UI is there. Then we have the real-time API beta. If I want to say, and why is this important? So if I want to change the voice mode currently, or I want to change the latencies, then this is where I will go and make the change. Now this OpenAPI, the first part, this is in the, I have uploaded that. This is the console part, which is I forked it, and I use, this is the VS Code, or rather cursor. So I am using cursor for making all the changes to the UI. I find it very effective, very easy to use, from adding various bosses, links, functionality, modals, and so on. And here right at the beginning you will see that it is making a call to this real-time client call. This is making a call here. So if I want to change the voice or the parameters for API, then I will need to import, I will need to fork this GitHub repo. Not, this is a package now, right? So then I will need to come here, I will need to fork this fork or clone this GitHub repo, and inside my code I will either need to directly call that GitHub repo, or compile it and call it as a package. So I have already forked it. So for instance, this API, this is that real-time API, the second layer. Front end is in my cursor. So this is that real-time API, I forked it. So this is where, in case I want to change the voice, this is where I can change it. This is where, if I want to change the thresholds, the voice activity detection real time, if I want to change the threshold, the padding, the silence duration, how long to wait to mark the speech as stopped. So this is where I will need to make. But in case I want to customize this, right now I've used directly their package, then obviously, like I said, you will need to clone it and then point it to your cloned directory. Now if you do not want to build it with a ready-made ready start packages like this, to prototype it, and you want to build from scratch, so real-time, OpenAI has got excellent documentation. This is it's based on WebSocket, so to maintain a continuous conversation, right? The documentation is very extensive in case you want to build something totally custom built. And in case you want to make a start here, you simply clone in case you want to make a start with the OpenAI real-time one, you can use that one. Or in case you want to replicate this, you simply take this, clone it, install npm start on your VS Code. It will be here when you install npm install, and then you do npm start, and it will open. You will get the whole interface immediately. It should be working on your local host. On the local host. I typically directly go into, as soon as this starts working, right at first point, I go to Vercel and deploy it. So that is available on my internet, and internet ID, web ID, and I can continue to, I can check how the production deployment is working on an online basis, right? So this is the UI piece, the UI piece, and the changes here, all the changes in UI which are to be made, these are all the boxes which I have added on the top, and the colors in the boxes, these are all made with Cursor AI, right? So my preferred tool for this kind of task is Cursor AI, which is this one, which is this one, and there are a whole lot of videos available. In my previous videos, I have shown how to use Cursor AI for making changes with text with natural language. For Python and machine learning and analysis work, for Python and all, which I work on Google Colab, where I'm not using a scripting or a code base like this, then I prefer to simply use ChatGPT. So that's regarding the all the front end part. The work on front end UI changes, it happens in a continuous manner. Now next step we will go into looking at how the various, all the setting up that backend. It's basically one single main React agent to keep. Now let's look at how all the backend agents are set up. So I have consolidated pretty much like I showed in the and in the previous architecture overview, all the backend agent pretty much is only a single React agent which has got all these tools. Now, how do I set this up? Now, at this point in time, I am going to refer you to one of the guides which I had made just before the YouTube, which was made playlist to how to build voice agents with LLM action agent. So this is a playlist, and almost 80% of the backend, 80-90% of the whole backend setup, hands-on step-by-step guide. It's almost 2 hours plus of videos where I am covering almost 80% of the backend is covered. So in this series, this is a 5-part series, and in this series I cover from a start with an overview and then go into detailed into how to update the Excel in the Google Sheet and the trackers for it, very step by step, how to set up the webhook, connect the webhook, and so on. Then how to set up the Google script, how to and how to do many of these things using ChatGPT and AI assisted coders and ChatGPT and so on. Then I have a separate video on using building AI app with natural language with Claude Dev and Cursor AI. So it's a 25 minutes video where I walk you through how to use Cursor AI for this task. There are excellent videos otherwise also on YouTube on how to use Cursor AI. That's my preferred coding tool for this kind of tasks. And then I have a separate video for various other agents, how the database agents and the search agents and so on. So that will if you want to go very granular at a very hands-on level, then that is going to be a great resource. Now another very solid, very important resource for Flowise AI is Leon Van Zyle's videos on Flowise AI. So whatever I have learned on my learning, I learned with the Van Zyle's tutorial only. Very excellent hands-on guide, step-by-step guide. So wherever you are getting concerned and any issues are happening, then Van Zyle tutorials are the best. Pretty much everything that we are doing there is some way and form it is covered there. And as I had shared in my earlier videos also, for make.com, it is Nick Sarev's tutorials and are wonderful. He has got a whole wide range of applications, mind-blowing applications made in make.com. Okay. Now what we will do is we will now go tool by tool. Here we will go to basic agent setup. As well as and then go to tool by tool. So the basic agent setup is very clear. This is a simple. I will be sharing all the JSON schemas for this, so you can import that directly and you will get this. Or I think it is sometimes more efficient just to add the tools one by one, so you can check the performance of the tools also. So this is a node. This is a tool agent. This is a tool agent node in Flowise. You set up a new chat flow tool agent. LLM agent that I am using here is OpenAI, and for a detailed hands-on walkthrough, it is covered in my video guide as well as Van Zyle's one. Otherwise, it's very simple to look at the nodes and attach it. Buffer memory I'm adding. So that is the basic setup, and then all the tools get added. So now let's go into one. We will go into one tool at a time. And okay, now let's look at the database tool. I will just magnify this. So among all the tools, right, we are talking about the tool Azure MySQL. So what does this tool do? So this tool at the backend, it is connected to the my AWS and Azure data warehouses. You can connect to any warehouse. So once you get a user query, it converts that into an SQL. From that SQL, then it executes that query. So let's see how the tool is how this tool looks like. So this is how the tool, and all these JSON schemas format for all of these I would be sharing, so not to worry. So this the tool here converts the text into an SQL query, and that SQL query is then passed on to my fast API server on render. Now for this specific tool or this app, this can be a standalone app only, right? It can just be a standalone app where you have this UI or any UI and talking to the database. So for that I had created a separate guide, a very detailed guide. This is on Medium, along with there is a YouTube video also, and there is a Medium guide also. All these links will be shared. Building an analytic assistant LLM app connected to live data warehouse. So it is a step-by-step guide. Step 1, step 2, what the code is and how it works and what it does. But just to give a basic idea, the way this tool works is user sends a natural query in natural language, so the tool or the LLM app that will convert that into a TXT, into a SQL query, and that SQL query, it passes on to a fast API server. So I have an intermediate server. Intermediate server which establishes the connection with the backend data. It passes the query there. So then the data warehouse, it takes the query result, it is passed back to the fast API server, and the fast API server will then send it to whoever is making that call. In our case, it will come back to here, this tool agent, it will get the call. And since this is connected, if I'm directly using this, I will see that on that screen which I showed you. And if I am connecting this to the real-time API, this tool the result will be passed onwards, right? So that's all to it, and all this guide is there. It's a detailed guide, going through each step, what the code is, what it means, and what all those. This is the fast API server code. This is how we are establishing the database connection. Then there is a select query and a non-select query. We can transform data also, add file, delete file, summarize and put it into a new file. And then there are various components, and deploy the fast API code, how to deploy it on the render. So once it is deployed on the render, then how to set up this custom tool. So that's the guide which is available. And the React agents, what is its job? Its job is to take the user query, first figure out which tool is to be used. If this tool is to be used, convert that into a SQL query, and basically the parameters for the tool, execute that tool. Once the answer is received, answer is actually received in a bulk, into a bulk as a TXT file. It doesn't just serve that file directly, right? I'm not doing a return direct of the result. It takes the result, reads it, looks at the user query, what was user's query, and takes the relevant part of that answer and shares it in the format requested for it, right? So that is the that's about this tool. Okay, now let's look at the next tool, what I call the tracker tool, or reporting automation tool. So what does this tool do? So this is the custom tool. Now what happens with this, or what is the outcome which happens with this tool? This tool, as we had seen in the demo, it updates an Excel sheet. So we had seen that this is updates an Excel sheet. It updates a Google Docs also, an Excel sheet also, with whatever is the tracking item that we want to share. So and in addition, if I say that please send me the report format, so it will send me a PDF format report and deck format report. I had covered this in that 5-part series demo, as well as details how it works. But essentially, this is a tool which can update your Excel sheet, it can update your Google sheet, it can send you a report in a PDF format, it can send you a report in the deck format. In addition, this updates the data back in the backend database, and we can see it here. I can see it here, or Excel. I can see it in Excel here. I can see it in full screen if I want to see it here. This is the actual data, right? Now, how does that work? Let's trace the flow of this tool. So this tool, if I see, I'll go into that tool setup, and again all the codes, schemas, all those are available. So here, what does this tool do? The reasoning agent for this, it has to take the user input, and it has to convert the user input into these field type. What is the type of respect and the headings and so on. It has to convert, and it has to find out intelligently 3 use cases for whatever IAM user is suggesting, if it is an update. Then once it has done that, it has to execute an API call. So it takes this data and it executes an API call. It executes an API call to this hook, webhook to make.com. Now we'll go there. What happens in this webhook? So let's go to the make.com webhook. So here, this is that make.com scenario. So from there, the request comes here. This is always listening. So as soon as it gets a request here, it updates the Google sheet. Then it goes and updates the Excel sheet at the same time, and it updates the same data in a MySQL database, because a Google sheet and Excel sheet, I might be deleting the data. So here it keeps getting accumulated. Now, if I say that please send me the report format, then what happens? Then it comes here. This is the report format. It comes here. This actually triggers a Google script. So here it comes. It triggers that Google script. That Google script takes that data from Google Sheet. It creates a PDF format and emails it to whichever email ID I have specified. And if I say deck format, then it takes same thing. A template is there, so deck is prepared. Google script deck is prepared, and it is sent to that email ID. So that's the basic setup. So all this part also, this specific tool I had covered in the video which I had covered. This is covered over two pieces because a lot of important concepts are covered that connecting to webhook, your tool, JavaScript schema, and so on. So in two parts I had covered that, video number 2 and 3. And what do we have in video number 2, or the guide 2 is a 43-minute guide going in detail about how the custom tool makes a function call, and connecting it to make.com, connecting Flowise to from collecting that to RDS MySQL and so on. And in here I go into how to set up the Google script, how to create a script right from zero using AI assistant. So how to give the instruction to the AI assistant, how do you create that script, how do you save it, how do you publish that script, and you have to deploy that script, take that URL and put it in this thing. So a very detailed this thing is covered here. So we have now covered this tool. Okay, now let's look at the next tool. So the next tool that we have is the URL scraper or the web scraper, right? So what does this tool do? So when a user says ki here is a URL, like I had given the example of this Wikipedia senator URL, here is the URL, and all that I want is say this table, or I don't want this table, I want this list of senator, or I want some other component in some particular format to scrape it. That's where the scraper will you share the whole URL and you tell them what out of that page you want in what format, and it will execute this tool. It will execute this tool. So let's go into this tool and how it works. So I'll go into the tool. All these are available. So this tool takes a URL and then scrapes and shares the text in a markdown format. It just takes a URL. And what does how does it work? Very simple setup. I use a platform called Gina.ai. So this is one of the this is one of the web scraping platform very suitable for LLM apps. So Gina.ai. So I just take that whole URL and send it here. Finished. Matter over. Once I send it here, what happens is it goes there. I get a whole thing in a text markdown format, which the LLM is able to see very easily. So let's see. Let's just try it out. See, this is Gina.ai. It has got the most simplest way to use this all. Gina.ai, so it has got a bunch. So this Gina.ai is here, and it has got a bunch of things that it has got embedding, re-ranker, segmenter. I have not tried any of them. I have used the reader. Immense, huge free tier is like, I don't know, billions kind of thing. 100,000 available tokens, huge free tier they have got, and very easy to use. Reader means I just whichever URL I want to scrape, I just suffix it https r.gina.ai and put my URL here. So this is the senator ka URL, right? So I put it here, and if I want to scrape it, what happens is here this is the example we are showing, but you can do it programmatically, right? There Flowise it happens programmatically. When I'm automating, I send it via Python script. So it returns a markdown format like this. The whole text is nicely organized. So very nicely section wise it is organized in markdown format. So this is a very easy. All the HTML tags and all are removed. All the hyperlinks, everything is here. This is very easy for an LLM to read. So it is extracted. It goes to the tool agent, right? It doesn't serve directly. So tool agent or the reasoning part now again comes into play. It says, hey, what has the user requested? It has requested for this data, whatever is here in this data. It has requested in so and so format. So it picks up that relevant portion, formats it and sends it. So very powerful stuff. Now using it in this tool as part of the agent system, if you have a handful of URLs is fine, but I have used Gina.ai for many of my, or pretty much all of my web scraping project. There I am scraping hundreds and thousands of URL, right? That, I mean, of course it is done via Python. The URLs are part of the URLs are sitting in a database. Part of the URL are constructed depending on what the use case is. The data is pulled. It is pulled across multiple pages, first page, second page, and then it is pushed into ultimately into some database. And also even for automated web scraping, Gina is very simple, straightforward to use. Now there are many other web scraping platforms for LLM apps which have great capabilities. I have not tried them out. Firecrawl is one of them. Scrapegraph is one of them. Crawl for AI. Many of them can take it can go to a website, take a image, a whole image snapshot of that URL. That makes matter even very easy, because if there is something which is difficult to scrape with text, you can take the image, and I can take that image, and that image I can send it to OpenAI or one of the OCR endpoints to do OCR. If something is not directly readable as a if there is something which has to be checked with vision. So that's this tool, very simple to use. As far as setup of this tool, of course I'll share the JSON schemas, but in that 5-part guide which I had shown how to, even if you have to create a new tool, and even if you have to create a JavaScript function like this, how do you go about creating it, or basically how you can use AI chat GPT to create this tool, and what do each of them actually mean. Okay, so the next tool is the update document tool. What does this tool? As we have seen, this tool here we have all these docs. So this docs is a Google Docs, right? Currently it is empty. So this Google Doc, why is it here? It is here that in case as we are discussing anything either with the real-time agent or with the non-real-time agent, both of them are in a backend is pretty much same. So if there is anything which is which I'm discussing, and anything which I want to push into text, basically push into my document, like I had shown in the example, we had got the results from the web search, and now I want that set of result in my documents. We can always copy paste, but it's just to demonstrate that whatever is the output you get, whether it is small, big, you can push it into any kind of document. We can, depending on the kind of data, we can push it into Excel. Here I'm pushing into a Google Docs just to demonstrate that that concept or that piece. And how does that work? That is a relatively very simple setup, just like the tool tracker which I had shown earlier. How that it's the same kind of a setup. If I go here, if you look at the tool, what does it do? It takes all this data, or whatever is the user this thing in format. It takes all that data, and it executes an API call. Where does it execute an API call? Here. This is a make.com webhook. But it takes the data, sends it to the make.com webhook. What happens in that webhook? It comes here. It is just a very simple, it is just connected to Google Docs. Here I would have given the file, you go there and I would have chosen and given the file name. So how to connect the make.com webhook and all that I had covered in that part 2 and 3 in very detail. You are discussing, you feel that okay, I want to push this into my data, so you say that push this into can you push that into my docs or my files? It will take that and it will push it into this Google Docs. This Google Sheets and this Excel sheet, this is for tracker and automation. This is for pushing our things. So like that we can have whole variety of various documents which are being automatically generated, updated, queried, and so on, and we can look at it from here, or we can open it in full page view. Okay, so next tool is what we call the code interpreter tool. So what does it do? We would have seen these charts. So these are charts which are created on the Python on whatever data we have here, or it can pull the data from warehouse and create that chart. We had also done the hypothesis testing, if you remember. We had asked for response rate, whether they are significant difference or not. So that is happening by, so all the statistical analysis it is happening with the code interpreter tool. So let us look at this tool. This is the code interpreter tool. It is a node available directly, and I will take you to the website of this. It's a very powerful feature. You can use it inside Flowise, and like any of the other tools, you can use it outside in case you have some other application. You can directly call it via JavaScript, TypeScript, or Python. So this code interpreter tool, what it does, it based on the user request, it is able to it takes a Python script and runs it in a sandbox environment, right? So whole script has to be given to this tool, and it will run that in a environment, in a sandbox environment, just like the GPT plus code interpreter. Even GPT plus code interpreter, it can do statistical analysis, machine learning, charts. So same thing, code interpreter can run a Python script in a sandboxed environment. Very easy to, it's a lovely feature with Flowise. They have added a node. There is nothing to be done here. I just picked with this node is directly available here, right? E2B. So this node is directly. This node is directly available from E2B. You just add it, you connect your credentials and connect the node, and you are done. It's finished, and you let the agent know when to use this tool. That this tool has to be used whenever you want to run Python script or statistical analysis or charts. That's it. Now this E2B, it is this. It's an again open source runtime for executing the AI generated codes. It's got excellent use cases and all that they have shared. You can use it in any kind of your app, maybe a Python base or a JavaScript base, whatever your app may be based on. You can use it whichever you can use it with either of them, but ultimately the code can convert only a Python script. So your app your app will have to send it to an LLM to get the Python script which it can run, and it's very simple to use. JavaScript, Python script, and JavaScript and TypeScript is, they have said the code extensive documentation. Python one is very simple to use, pip install so and so, and then you install the libraries, whatever code you want to run, you just get the code done from LLM. You ask the LLM to run the Python code and you send it across here, short run code, finished, matter over, and you get back the output and the results. And I have tried it with more simpler use cases. I have tried it with simpler use case of charts and hypothesis testing. I'm sure it can do more complex use cases, like where you need continuous script after script to be run, like a machine learning. Okay, next tool is the Yahoo Finance Agent or Yahoo Finance React Agent. Again, it's a React reasoning and action agent. What does that tool do? As we have seen, it is basically given a Yahoo Finance code, it can pull out the stock prices as well as the various results from Yahoo Finance, quarterlies and the balance sheet and P&L and so on, and prices. We have seen how we can pull out those prices. We also created charts and graph, which was done by the code interpreter. So let's see how this tool works. So this tool I have kept separately here as a Yahoo Finance agent. So this is only the Yahoo Finance agent, but there are no other tools here, and we will see. At the same time, in this main agent also I have attached this tool as a part. I'm just experimenting, whether it works more efficiently separate or together. So it is available in both the places. I've seen that it works more efficiently separate, because sometimes for some financial results, stock prices, a financial result, the task agent tends to use Google search rather than the Yahoo agent. So how does this tool, where does this tool fit in the scheme of things? So here this is a chat flow tool. If this chat flow node means I can add another chat flow or another agent, and it is calling this tool. So this whole thing, I can create one React agent and call it in this one. So this itself is a React agent here, which is being called. So keep in mind, at this point in time here, this is actually 3 React agent, one after one, each other in sequence. If I am using the real-time API, first is the real-time agent, real-time API. Since why is it a React agent? Because I have attached a tool which calls this agent, main agent. This agent for one of its tasks, which is Yahoo Finance, it calls this agent. So it is 3 agents, in sequence. So let's look at the Wi-Fi UI agent tool. So this tool is there to provide stock price data, financial statements, and also let's see how this tool works. So this is the tool. The way it is organized. Now this tool has got. Let's look at what this tool has, and how it works. So this tool has got separate tools for P&L, balance sheet, cash flow, quarterlies, and so on. So this is not, I won't say this is the most efficient format. This was something which I had made around a year back. I was just figuring out things. So it is much more better to just combine everything into same way, and I'll let you know how we can do it. You can do it in case you want it. But one single box is enough. And I've also given it Google search if you want to search for Yahoo symbols, and also it will just search on its own. And this is the code interpreter. Why do we need the code interpreter here? Because I might, in this tool, if I'm using this tool, I might want to create charts and graphs, right? So primarily for charts and graphs. It can do, I'm sure it can, if I put stock prices, it can do time series also, but I have not tried that. Now let's take an example. What happens when all these tools, all these separate tools, whether it is PL, balance sheet, all are very similar looking. So we will just take take one example. Say I ask that to give me the income statement and P&L for this, pull this one. So what happens? This tool. Let's look at this tool. So this tool symbol, it just needs one. So the React agent is supposed to pass it the Yahoo Finance symbol. Right? Once it has passed the Yahoo Finance symbol, what happens? It makes an API call to this place. API call to, I have again fast API server on render, which is running a Python code. Fast API server means Python code. So we will just see that Python code. So it is running a Python code, and it takes the parameters and input. Now this is where the issue is. I created separate endpoints for income statement and for balance sheet and so on. And there is no need to create a separate endpoint. You can just pass that as a parameter, right? And single endpoint it can go to. So from here it goes to the fast API server, which is running my Python code. So let's see what's that is deployed on render. In my in the video guide which I've shown you how to deploy fast API, how to set up a fast API server, how to deploy it on render. So let's see what is happening in the Python code. It's a straightforward, very simple Python code. That's just to demonstrate that any kind of Python processing that you want to do, you can do it. you can do it if your server has got Python. Like code interpreter is one way to go, but maybe I may not want to use code interpreter. I might want to pass a script and do it at my end, some processing my end. So fast API server is a good setup for that. So here this is this is that YFin Pi. It doesn't make, here I'm basically using the Y Finance library. You know, earlier the API and all that used to be official. Now I think, you know, it works. It works. So in this, it is just the Y Finance library. It has got its coding syntax. I had GPT create the fast API endpoint for it. There are different endpoints. You know, there are different. All those functions are created, and all those functions are created here. The syntax is from the Y Finance documentation, and you know, all these separate endpoints are created. This is where, you know, no need to create this separate endpoint. You could just pass a parameter and it just executes that whichever function, whatever function is there. And this is the Y Finance syntax. But the important concept here is that basically I can run a custom Python code, either not just a code interpreter, but I can run a custom Python code with my custom data connections on a server using a fast API server setup. So that's all to the tool. All the tools are very similar. Now we come to the last tool, which is the Google custom search. So you know, you would have seen in the demo, I was asking it to create. I was asking that agent, you know, can you do a Google search and share the for ARXIV PDF research papers for in ARXIV site and share the top 5 and so on. So it is basically our regular Google search. There is the intelligent part there is that, you know, when the whole search results are come, the React agent is, it can look at that search, it can draft the query, it can look at the search and, you know, pull out and share the data in the format that we need. So how does that work? This is a very simple, straightforward thing. Nothing to be it's available as a direct node here. So this Google custom search, it become very tiny here. So this Google custom search, it is directly available as a node here. From available, I don't need to set up anything. I mean, I need to get the API key and the credentials. So you just drag and drop this thing, you connect the credentials. So in the credentials, so it has got instructions on how to create the credential. Basically, you need a API key and you need a programmable search engine ID. I will give you a very quick idea. So this one, or I watched, there are many videos available for setting this up for Flowise, how to get that. I just watched one of those videos. I will leave a link in the description. But basically, you need to go to a Google ID, you need to go to API, enable the Google search API, then you need to get an API key, and then you need to go to something called programmable search engine and create a search engine there, and I think that's it, and you get those two IDs and you plug it in here in the matter over. And then the agent knows Google's agent looking at the tool, it can intelligently figure out when the tool has to be used. You can request it to do a Google search, or otherwise very often it can reason it out on its own, and when the output comes, that whole output, it can figure out, you know, what part of the output has to be shared based on the user query. In my earlier videos, you know, I had also shared Perplexity tool in that 5-part series. Here I had shown how to set up the Perplexity tool. It's very useful. Perplexity tool is, again, it's an AI based search tool, so depends on what you want to do. It is very useful if you want to list of top 10, top 20, top 100 companies and some, so it goes and directly picks out that kind of list. So for depending on your use case, you might want to use a Google search tool or a Perplexity tool. So till now we have seen in the first part setting up the UI and the API piece. Second part, we went in detail into how the backend is structured and trace the flow of the various agents. And again, let me tell you, all these GitHub repo is public, so all the codes are there for all the make.com workflow, as well as the Flowise, the chat flows tools, the blueprints, the JSON schemas, the whole JavaScript codes, and all those all will be made. All are available. I already shared that in my previous video. I'll again share the whole thing as part in the GitHub. In the GitHub repo, it will be available in a separate directory, JSONs or something. Everything will be there. Now the last part is, we have to now connect that agent, this agent that we created, this main agent which we had, this main agent that we had, as well as the agent. This one we now need to create it to our UI and front end. So how do we do that? So The way the UI is currently set up, this is that what is called the console page or the first page. You go into console page.txs. This is TypeScript. I'm not conversant with TypeScript. I just understand it intuitively, some of it, and most of the work I use cursor AI to make the change. So it is this is I'm using the OpenAI's own library. So what they had done is there's an add tool section here. So they already added two tools. So all that I did was they had added a weather tool and they added a weather tool and a set memory tool. So weather tool, I took this example. This is the way, basically this is a function call, right? So you are just giving a function, setting up the tool for an agent. Flowise you do it, ultimately backend it is the same way. So I took this code and gave it to cursor AI, or I actually used ChatGPT there, please give me a code in this fashion. Then I asked cursor AI, okay, please, this is my actual agent API endpoint. How do we get the API endpoint? This is something I had shown in the earlier that 5-part series, but I will had shared in the earlier part also. So here you go into the code one. If I just want to embed the box directly, the one that we get here, this tool agent, task agent, when I open this one, so this is a simple link. So where do we get this? This is the Flowise owns user interface, very effective, immediate, you can deploy that. You get in share chatbot. Again, all this detail how to do I had shared in the 5-part guide, but I will show you very quickly. So you get this link, you make it public, and then you that's the link for the UI. But if you want to access it via backend, then this is the prediction endpoint. So this is the prediction endpoint that you need to use. So then you take this API endpoint and you set up the tool agent. So then you set up the tool agent here, and I had asked you can use this and replicate it, but typically I ask cursor AI, give all the details and ask it to do it. So if you see here, I would have set up a tool somewhere. This is my tool, add tools. I am calling it tool multitask API, and I have given a description. Now this description is important for the LLM model API, real-time API, to know when to use the tool. So it is a tool when user requests this, then use this, so on so forth. All those functionalities I had described here. And then this is the same API endpoint, right? V1 prediction. So I give the URL is given. So the URL is given here, and then there are other things for getting the response. Another thing which I had to do was that response can come as a TXT file, or it can come as an image, or it can come as a chart, can come as an image. It can come as a text. While my database fast API server, there I am sending out a response as a .txt file. So this code had to be structured accordingly so that it can take either all three types of responses. So all three types of responses. So that's it. You just add tool here. This is you add tool here, and we will come to this piece. There is an image artifact which is coming here. These are things to manage the various streams that it should be. This is to manage the blob, the data, and the image, and so on. Right. So that is that's the connecting. With that, then this agent is connected. So typically, as soon as the first and right at beginning I deployed, by the way. So any point in time you are working, how to deploy in Vercel I had covered in my this guide. I had covered in I think 2-3 places. I have deployed to Vercel and go live very step by step, and actually 2 minutes, hardly take less than a minute. You point to a GitHub repo, deploy, within 1 minute it is deployed, matter over. So now you have connected this Flowise. I have taken that API endpoint and connected it here by adding it as a tool agent. So again, I'm pointing out, so here this real-time API now becomes, with that it is now actually a React agent, right? It will reason which tool to use whether it should answer on its own or it should use the tool. So it is this React agent. Real-time API is a React agent which is calling the second main React agent, and if I request Yahoo Finance data, it's the third React agent, which is this one. I have kept it separate also. So this is actually 3 React agent in sequence. Not I use this structure because I have kept all those agents separately, so I just plug and play. You might want to simply collapse everything into one. That's an architecture choice based on the use case. So now this is connected. This is that same Yahoo Finance agent which I had shown earlier. All that we have done here is this is a hyperlink. You open this and this is a hyperlink. That's it. Nothing much to it. I asked again cursor.ai. I told them that I want a box like this, looking like this, and I want a zap there, and so on and so forth, and give me a hyperlink which opens in new place, and it will open the hyperlink in the simple hyperlink is there. Nothing much here. Similarly, this is also simple hyperlink, opens into a new page. This conversation box which you see here, this is already there in OpenAI's this thing, so I have continued with it. You can modify it, I don't like the formatting, and also it was earlier only text. I tended to a React Markdown, but you can change it. These events and voice activity that you see, this is also coming from OpenAI's main code only, so I've just kept it. I've just made some space between these two and put this here. Now let's come to chart display. The chart display, where does this chart display come for all the charts that we are requesting? It comes from the code interpreter. And here, when we are this code interpreter tool, when we request, it sends us a backup image. So picking up that image, it took me a little. Earlier it was not getting picked up, but ultimately Cursor AI and the GPTs figured it out. But I was still getting stuck in the URL. So this is one very important part. Code interpreter, when it sends the it sends the file. When it sends the file, it doesn't send the file. It sends the image.png. It sends the name, the png. It sends the png file name, right? So png file name is sent. So then we need to, at our end, we need to reconstruct that URL. We need to reconstruct that whole URL where that file will be attached, that dot file name, and then pull it out. So how does that look like? I just did a right click. I just made a graph on my main agent and did a right click, view source, and got that URL. And then I asked Cursor AI, okay, use this to figure it out. So then it did the rest of it. So how does that URL come? So this is that URL. It was here when we were looking at the chart image artifacts. That is it. So this is the image URL. So this image URL, this is the format you have to keep. So whichever app you might be using. Now, if you are using the native, this one, you do nothing to worry about, right? If you are using the native this chatbot, then you don't tell. So the image URL is. So how is the image URL organized? It is like this. It is the URL of your. I have a custom URL, so it looks like this. So it is the URL of your chatbot. Basically, this is the URL of your. This is the URL. This is the base URL of your chatbot. Mine is a custom domain. Otherwise, it will be this base URL. This is the part which I had covered in the earlier part. This is the base URL of the your chatbot, and then API we even get upload file, and then you say chat flow ID. So this chat flow ID is your chat flow ID. It is fixed. It is for the chat flow itself, which is this ID, this one. So this is your chat flow ID. It is fixed here. It is the same thing which is here, this part, right? So you take this URL, chat flow ID, and chat ID. So that is chat ID is for that specific chat. So that is the JSON response chat. So it is a variable which you will pick up as a from the response itself, and then you get a file name. So again, from the response you get the chat ID, and from the response that you get the file name. So this is the PNG file name which is passed here, so that then we are able to see the chart is rendered in this display. So the OpenAI one, they did not have this chart display and all that, right? Something else was there, weather or something was there. So I, working with Cursor AI, I told them, I want a chart display. I want this kind of a collapsing thing which I want, and this chart display, it should keep the historical chart. If I generate 10 chart, it should keep it in an array. So I can, in case I want to view again, I should be able to view again. If I click on it, it should become big. So all the charts are kept here. It is displayed. It is currently displayed here. It goes away when the section gets disconnected. But in case you want to save the chart, push it out, you can set up an automation workflow. So that is how the chart ID. That is how it is with the chart ID. Right. So now, and then this is this box. All those Google Sheets and trackers that we were setting up. These are just embed links. All that you do is say only one thing which is required here is, if you are using Google Docs or Google Sheets, you have to go to File, you have to do Share, then you say Publish to Web. Once you do Publish to Web, you will get this embed link here. You say Publish, this is published one, and then you get this embed link. So this is the embed link which I basically went to Cursor AI, and I told Cursor AI that here is the embed link. This is the kind of box I want. I gave the specification the way I want the box to be, and please do the needful. So I had to give the specification detail. It took many iterations actually. Doesn't happen this thing. So I wanted this box in a collapsing way like this. This button will do like this. This button will do like this, and Google, Excel, and Docs should be here. First, it should open in a small view here. When I say something like this, then it should open in a full view like this, right? I should be able to edit it and do something. So I should have the option for small view, big view. Same with Excel also. Excel also, when you are having an Excel SharePoint, I'm talking in the SharePoint version, you can go to File and you can say Embed, and once you say Embed, there are a lot of embed options are there, and then I don't want to see all this menu item, right? So then you give this embed code, you take that embed code, give it, attach it to whichever way you want it here, and it comes. And if you want to open it, just open it in full size, it's already there. So as you see, as you see now, we have all these are formatting things, image, these are formatting thing. I want to add this title on the top, I wanted to add these titles on the top. So Cursor AI did it and guided me. Okay, this is how you set up for basically formatting stuff. Nothing much there. Nothing. Remaining is pretty much the same. There was this icon spinner which I added. So with that, if you see, we covered right from the demo. At this point, we covered the how to set up the front end, how to set up the back end, how to set up the and how to connect. So in case you want to get started, if you just clone the repo, that my own repo, or even the OpenAI, you clone the repo, you do npm start, it will start. You put up the RTAK, it will start talking. Even this task agent will work. This API key that you see here, this API key is for, it's very expensive, so I've kept it here. It is work there in OpenAI as one. So this API key is for real-time agent. If you just want to try out this demo site is available. Demo site, you can go anytime here, and you want to experience the real-time one, you can put your API key. If you want to just play around with these two task agent, it is free to use.